Hi everyone. In this video I'm going to provide demonstrations of path analysis using the Lavaan package in R. The Lavaan package actually has a couple of functions that are available for carrying out path analysis. One is the SEM function and the other is the Lavaan function, and I'm going to mainly focus on demonstrating the Lavaan function. Now I'll be making available a copy of a CSV file containing the raw data that we're going to be using in the demonstrations underneath the video description. So be sure to download that if you want to follow along. Also, I'm going to make available a copy of this text file as well. So again, there will be a link underneath the video description for you to download it. As I go through the demonstrations, I will probably do a lot of copying and pasting from this text file in order to save time. And to tell you the truth, it's not a bad strategy anyway when you are having to write a lot of code in order to carry out analyses using R. So for starters, let me just note that if you have not already installed the Lavaan package, you're going to need to do that. So you can use the install packages function. Inside, basically just type in install.packages. Inside the parentheses, you'll type in Lavaan, and Lavaan is enclosed in quotes. And just keep in mind that Lavaan, the letters are all lowercase. So once you've installed the package, then you can just use the library function in order to call up that package. So you can just type in library and inside parentheses type in Lavaan. Now once you've downloaded the data, you can actually just use this code right here. You'll need to point the R program to the file that contains your data. And once you've done that, then you can just basically use this code right here in order to essentially import your data into a data frame that's called process data. So this is just an arbitrary name that I'm using. In fact, I'm just going to go ahead and copy this and open up R and get started. So you'll see we have our R console. So what I'm going to do first is just type in library Lavaan, and so now that that package is active. Next, what I'm going to do is just go ahead and paste in that code that I was telling you about. So right now, I've actually got the CSV file downloaded. It's actually underneath my downloads folder. So in order to point the R program to the folder or file that's going to contain the data, you'll need to go to Change Directory, and I'll set it as underneath Downloads right here and click on OK. So that now when I hit Enter, it will read the data in, and now we've created a data frame that's called process data. To take a quick look at the data, I'm just going to type in str and then type in the name of the data frame, which is process data. So this is going to allow me to look at the structure of the data. So you can see it's a data frame. There are several variables in here. We have SES, that's going to be socioeconomic status. I have gender identification, performance goals, achievement, mastery goals, interest, and anxiety right here. So we're going to be working with some of these variables from this data set. So going back to our text file, the first step in using the Lavaan function, you're going to need to use the Lavaan model syntax to specify the path model and have it stored in its own R object. So in our model, we're going to treat SES, mastery goals, and performance goals as predictors of student achievement. And the effect of mastery on achievement will be both direct and indirect, the indirect route flowing through interest and anxiety. And the effects of SES and performance goals will be treated as fully mediated through anxiety and interest. So let's just take kind of a quick step sideways and just get a visual of what we're talking about. So what I've actually done is drawn up the models. Actually, I use the Amos program because it's got a fabulous user interface. But basically, this is the model that we're testing. So you'll notice that we have SES, mastery goals, and performance goals, and we're looking at these are the exogenous variables within the model. And these variables are going to be predicting achievement. Mastery is predicting achievement both directly through this route right here, as well as indirectly through interest right here, and anxiety right here. So this route right there. Then we've got SES affecting achievement only through this route right here. So this path and then this path. Then we have performance goals affecting achievement through the interest variable. So that's the mediating variable there, and then through anxiety. So anxiety is a mediator there. So all in all, the number of parameters that we're estimating is actually 18. And so when you're using your syntax, it's probably not a bad idea to just draw out your model anyway and think about the parameters that are being estimated. So within our model right here, we have to think about several sets of parameters. One is the variances of the exogenous variables. So right here, I just typed in exo right here. So we have basically the variances of SES, mastery goals, and performance goals that have to be estimated. In addition, we're estimating the covariances among our exogenous variables. So there are actually 3 covariances that are being estimated. We also have the variances for the residuals for each of our endogenous variables. So an endogenous variable within our model is basically any variable that has an arrow pointing to it. Our exogenous variables are those that don't have an arrow pointing to it. So you can still have correlations among them, which is signified by the double-headed arrows. But an endogenous variable actually has the arrows pointing to them. So because of that, they each have a disturbance term, or basically it's reflecting residuals, or essentially prediction error. So we have essentially then 3 residual variances that we have to estimate. So I've just got this denoted as E1, E2, and E3 right here. So those are the residual variances associated with the 3 endogenous variables within the model. We also have a residual covariance between these 2 endogenous variables. So I thought I would just include that to show you a little bit more about the syntax that we're going to be using in Lavaan. And then we have 8 path coefficients that are included as well. So again, if we add up all these parameters, they total 18. So basically right here in this section of our syntax, this is basically our model specification. So also note that when you are working in R, the pound sign is representing anything that follows on that line is considered a comment. So basically the program is not going to recognize or try to do anything with it. It's just going to recognize that there's a comment and that's it. So the the object that we're going to write, or the syntax that we're going to write, is going to be contained in an object in R that's going to be called model. Okay, and so that's just my arbitrary name. You can name it whatever you want, but you'll notice I've got model followed by the less than sign and then a hyphen, which is obviously creating an arrow. Then importantly, you can see that we have a single apostrophe right here, and this is starting the code for our model in terms of our model specification. So basically anything following that all the way through the end of our model specification, everything in there is going to be recognized as the model specifications. So within that, you'll also notice that I've included pound signs, and these are just comments mainly to help articulate what each of the different sections are representing. So first off, you'll notice that I just have a pound sign and then equation where interest is predicted by SES and mastery and performance goals. And again, you can see right here I've got a second pound right here just to let the program know that this next line is actually part of that comment. So you'll notice right here we've got interest and then a little tilde sign right there, followed by mastery plus our performance goal variable plus SES. So this is the way this is laid out, is essentially in terms of an equation. So we have interest, which is one of our mediator variables, is going to be a function of mastery goals, performance goals, and socioeconomic status. Then you'll note that we go to our next line, and you can see that we have the achieve variable. So this is our outcome variable, and you can see that we have achieve followed by the tilde sign, and then we have anxiety plus interest plus mastery. So achievement is treated as a function of all 3 of these variables. Basically, our 2 mediating variables, which is anxiety and interest, as well as our exogenous variable, which is mastery. Then for the next portion of our syntax, we've got an equation where anxiety is predicted by mastery and performance goals. So anxiety is our second mediator in the model. The first mediator is interest. The second one is anxiety. So we have anxiety followed by a tilde, and then we have performance goals plus mastery. So you'll notice that anything to the right, the variables that appear to the right of the tilde sign, are separated by plus signs. So keep that in mind. Then I'm estimating the variances of the exogenous variables within the model. So that's our SES, mastery goal variable, and performance goal variables. So you'll notice to do this, we are now typing in mastery and mastery right here, but then it's separated by two tilde signs. So that's indicating that we are estimating a variance. And I've got performance goals, two tilde signs, and then performance goals, SES, two tilde signs, and SES. So in this case, now we're estimating the variances for our three exogenous variables. Then we want to estimate the covariances of our exogenous variables. So to do this, we're going to type in mastery, and you'll notice that we've still got our two tilde signs. Then I've got performance goals and then plus SES. So this is going to estimate the covariance between mastery and performance goals and mastery and SES. Then you can see I've got performance goals separated by the two tilde signs and then SES. So that's our third covariance among our exogenous variables. And just so you know, we could have just as easily said mastery, two tildes, performance goals, and then another line have mastery, two tildes, and SES. But this is a little shorthand right here that makes things a little quicker. Then to estimate the residual variances for our endogenous variables, you'll notice that I've got interest, two tilde signs, and interest, anxiety, two tilde signs, and anxiety, and then achieve, two tilde signs, and achieve. And then to estimate the covariance of the residuals for interest and anxiety, you'll see that I've got interest, two tilde signs, and then anxiety. And then again, we're going to round out our model specification with the single apostrophe. So remember, everything that follows between the first apostrophe and the second one is our model specification. And then, again, all this information is being contained in an object that is called model. So now what we're going to do is we are going to, so actually just really quickly, I'm going to copy all of this and paste it into R and hit enter. So at this point, our object now contains all that information. In fact, if I just type in model, you can see this is basically it right here. It just kind of keeps going off the page. So next up, what we're going to do is run the analysis. And we're going to be using the Lavaan function to do this. So basically what you'll see right here is this is the Lavaan function right here. And you'll see that we have parenthesis, and inside the parenthesis we have actually a couple of arguments. The first argument is the name of our object that we created up here. So this is called model. Again, that's just an arbitrary name, but whatever we call our object containing our model specification, we do have to use that down here when we use the Lavaan function. So we have Lavaan, I've got the name of our object, which is called model, comma, and then we've got data equals, and then process data. So that is our data frame that we were using. So remember back up here where we imported our data into this data frame, that's it right there. So now we're basically ready to go. And it's often a good idea just to go ahead and save the results into an object of its own. So I'm creating an object that is called fit, followed by our arrow right here. So all of our analysis results are going to be saved under an object or within an object that's called fit. So let's copy this and paste it in. And we'll hit enter. And so now you can see everything is actually saved. And if I want to look at the fits information, I can just type in fit, and you can see we have just a little bit of information on the model fit. In particular, you can see that we have essentially our chi-square test results right there. And you can see this is using maximum likelihood estimation. Typically, that's not all you're going to want when you're running a path analysis in terms of interpreting the results. So there are other commands that are available that will allow you to get a lot more information. In particular, you can use the summary function right here. So you can see right here I've got summary. Inside the parenthesis, you'll see I've got fit, and that is the name of our data object containing the results right here. So again, that's an arbitrary name, but it has to appear right here. And then you'll see I've got a comma followed by fit dot measures. That's a second argument, and it's set at true. And so what this is going to do is it's going to give us a number of parameter estimates as well as a variety of goodness of fit measures. So I'm actually just going to copy this and paste it into R as well. So let's do that. Hit enter, and so now you can see we have a lot more information that's available. So up here you can see that we have our chi-square goodness of fit test value. There's the degrees of freedom and then the p-value. Scrolling down, you can see we have our CFI that's given as well as the TLI, and both of these are really very low values. Generally speaking, what you're looking for in terms of indicators of good model fit. At a minimum, threshold is about 0.90, and a number of authors suggest 0.95 or above. So these are obviously very low, indicating poor fit. Scrolling down, you can see that we have our RMSEA value, which is 0.25, and basically values that are below 0.08 would be considered acceptable, and evidence of close fit would be values that fall at 0.05 or below. Scrolling down, you can also see that we have the standardized root mean square residual, which is another index of model fit, and so forth. So kind of scrolling down, I'm not going to go through every bit of this, but just to kind of notice, here you've got the regressions. So these are basically the unstandardized path coefficients within the model. All of them have their standard errors, z-values, and p-values. You can see that we have our covariances that we specified. So we've got mastery goals and performance goals. So there's the covariance, standard errors, z-values, and so forth. And SES right here, that's the covariance. Performance goals in SES, there's the covariance right here. And then our covariance for the residuals right here for the interest and anxiety endogenous variables. And then we have down here our variances for our different variables and also the exogenous variables and the residuals. Oftentimes you may want to get standardized regression coefficients and so forth, and maybe R-square values and so forth. So we can modify our previous summary our analysis with the summary function by not only including what we had before, but also you can see I've added a comma and then two additional arguments. So we've got standardized equal true, and then you can see I've got R square equals true. So if I copy this and paste it into the R program and hit enter, now you can see that, again, we've got all of the same information that we had before, but now we've got a column over here. It says std.al.all, which is basically just our standardized regression coefficients. So you can see right here, these would be essentially beta weights as you typically think about them in the context of standard least squares regression. So that's what that is. And if you scroll down, you'll also see that you've got R square values. So these are, again, these would be basically be indicating or used to indicate the proportion of variance accounted for in each of our three endogenous variables. If you want to obtain confidence intervals, you can certainly do that. The easiest way is just type in parameter estimates, use the parameter estimates function. Notice that E is in caps, so make sure that you have that right. And then within the parenthesis, we're using our previous fit object right there. So basically, I'm just going to type in parameter and then capital E estimates and then fit inside parenthesis. And so now you can see by default, these are 95% confidence intervals associated with each of our parameter estimates. So these are the actual parameter estimates. Again, we have standard errors, z-values, and p-values that are associated with them. A couple of other things to note: if you want a more comprehensive set of fit measures, you can certainly obtain that if you just use the fit measures function right here. Notice that the M is in caps, so basically we can just type in fit measures and then inside our parenthesis again our fit object. So let's just go ahead and do that. We'll just type in fit measures and then our fit objects, and so you can see these are a lot of these are the same indices that we saw before, but there are some others that are available in this output. Finally, let me just kind of note that you can also obtain modification indices as well using the modification indices function. The I in here is in caps as well, so make sure that that is correctly laid out. So I'm just going to paste this in and hit enter, and so now you can see that we have our modification indices. These are the values that are given, and then these are the expected parameter change values. And you'll see in the text file, if you download it, that I have a little bit of a note right here on making sense out of this. Let me also note that you can see that as we were going through, there was a lot of work in terms of laying out the basic model, and anything that kind of reduces the amount of work is a nice thing to have. So one thing that you can use is the Auto.var argument, and basically if you can lay out your model syntax in the same way, but instead of having to request directly the residual variances, you can actually leave that out of your model specification. And if you include, when you're running the analysis using the Lavaan function, if you include the argument auto.var equals true, then in this case it will when it's running the analysis, the variances of the residuals will be estimated automatically. And in fact, in this syntax that I've laid out right here, you'll notice that I actually included just a little bit of a comment on these two lines noting this. So previously, following the comment about estimating the residual variances above, I actually had the syntax for doing just that. And instead, I'm just kind of moving on to the next line where I'm estimating the covariance of the residuals, and that's the remaining syntax. So there you go. Now, as a last topic for this particular video, as it's getting a little bit on the long side, let me just note that there are some ways in which you can generate the path diagrams to kind of visually represent your model. But I will say that it's kind of tricky. They're kind of tricky to implement, and they're not exactly the most flexible things to work with. So what I've done is just kind of created some general code for the use of the semplot function and also the Lavaan plot function in order to our packages in order to just kind of show you what these might look like. But and in the text file, as you kind of scroll down, I've got information, resources on the use of Lavaan, using the semplot package, which I'm going to show you just in a second, and then using the Lavaan plot package, which is the other one. But again, these are not really my favorite things to work with. I probably would just as soon draw out the model using either a different SEM program that has a little bit more flexible user interface, or just simply do it in PowerPoint. But just to kind of show you if that you can do this, what I've done, I've gone and installed package semplot. That's one package. So we can call up that package using the library function right here. And then this is just a bit of code. And basically, you'll see that we're using sem paths. That's the function associated with the semplot package. You'll notice that inside I've got fit, and that's our fit object that we generated above. So everything else is just basically contains arguments that I've set up. So let's just kind of do this. I'm just going to copy this and paste it into R so you can just take a look at it. And this is what it looks like. So it's not, it's not really the most attractive thing, and I'm not really an expert at using this particular plotting function, but that's what it looks like. And you can, kind of play with it with the various arguments if you want to. But again, my general preference is to use an alternate approach to drawing. The other is the Lavaan plot package. So again, right here I'm just showing you can install the package, and then right here using the library function to call it up. And then this is, you'll see we're using the Lavaan plot function. Once the package is called up, using that function, and you'll see I've got model equals fit. So that's basically the first argument, and then I've got a number of other defaults that are given in here. So actually I'm just going to copy this and paste it into R as well, and I'm going to get rid of this and hit enter, and it takes a couple of seconds. And this is the diagram that I ended up with. So you can see right here, there's our exogenous variables, mastery goals, performance goals, SES right here. You'll notice that it's not allowing you to, it doesn't provide any correlations among those variables. But this is the basic model layout. And then you can see right here, these are the endogenous variables, anxiety and interest. These were actually the mediators in the model. And this double-headed arrow right here is signaling that covariance between the residuals. So at any rate, that's what the Lavaan plot function looks like. So at any rate, that pretty well concludes this demonstration. I know it was kind of a longer video than I ordinarily or lately have been putting together, but obviously it covers a lot of territory. If you like the video and the materials and so forth, please take time to like the video and share it with others. Thanks for watching.